All right, everybody, this is from 13.1. The first thing we need to do is learn how to identify the opposite, adjacent, and hypotenuse for a right triangle. Always it's dependent on where theta is. So from theta's perspective, of course, this is the hypotenuse. The opposite side would be down here because it's across the triangle from the angle. And this would be the adjacent side. The only reason I bring this up is because if I shift theta down to this corner, the hypotenuse remains the same, but now the opposite and adjacent sides switch because this is now the opposite side, and this would be the adjacent side. Now, that's just a little heads up as we go in and identify the values of these 6 trig functions. The sine of theta is the opposite over the hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. You might remember SOHCAHTOA. When we do the cosecant, secant, cotangent, it's actually just the reciprocals. So h over o, h over a, and a over o. Those are our trig functions. You'll want to refer to these if you don't have them written down. You'll refer back to this part of the video several times as we go through this. All right, so there's 4 problems we're going to look at today. First, we're going to start with number 6. And it asks us to find all 6 trig functions. You know, sine of theta, cosine of theta, tangent of theta, cosecant of theta, secant of theta, and cotangent of theta. In order to do this, I need to know all 3 sides of the triangle. Right now I have the hypotenuse and the opposite side. So I could develop sine right away. That's going to be 7 over 15, which makes cosecant 15 over 7. The opposite over the hypotenuse, and hypotenuse over opposite. To find this adjacent side, though, I'm going to use Pythagoras Theorem, which is a squared plus b squared equals c squared. So right now I'll have 7 squared plus b squared equals 15 squared. And if I have b squared, it will be 15 squared minus 7 squared, which is 176, if I'm right. I believe so. And that does not have a perfect square root, but it is divisible by 16. So if I take the square root of that, I will get 4 root 11. That's why I brought this one up. I know it's a little tricky dealing with that root 11. How do you get it from 176? Well, we divide it as best we can, and we get to where we are. And so now that we're here with 4 root 11 being this side, we should be able to finish. The cosine would be 4 root 11 over 15. Which means this is 15 over 4 root 11, which we know we're not allowed to keep the root 11 down here, so we'll multiply by root 11 on top and bottom to get 15 root 11 over 4 times 11, which is 44. Over here, the tangent is opposite over adjacent, which means I end up with the same situation, 7 over 4 root 11. I multiply by that root, top and bottom, to get 7 root 11 over 44. And over here in the cotangent, if I take the original and I flip it, that would be 4 root 11 over 7. And there's number 6. A little bit of work with that square root that we had to deal with. But again, remember, 176 is the root 16 times root 11. And this is a 4. That's how we get our 4 root 11. Moving on, number 14. They start with the cotangent of theta equaling 6 over 11. Now, if I think about my sine of theta, cosine of theta, tangent of theta, cosecant of theta, secant of theta, and cotangent of theta. I know this one is 6 over 11, which makes this one 11 over 6. Now I need to find that missing side. It's easiest if I just draw a nice right triangle and do some labeling. I'm going to make this theta. This says that the opposite over the adjacent. So opposite would be right here. This would be 11 for the adjacent. I need to find my hypotenuse. So 6 squared plus 11 squared equals c squared. That's 36 plus 121 is 157, which doesn't have a perfect square root. And I don't think it even has something that we can use. Yeah, I think we're pretty much stuck with the square root of 157. Let me check real quick, make sure that doesn't simplify down. Nope, that's going to be just the way it is. Nothing we can do about that. And that's okay. We're not afraid of that. So that's our hypotenuse. So the sine would be 6 over root 157. But we know we have to change that. So we're going to put 6 root 157 over 157. Similar thing happens with cosine. I would get 11 over root 157. So I'm just going to straight go to 11 root 157 over 157. The opposites, the cosecant and the secant, the reciprocals, would just be root 157 over 6 and root 157 over 11. And there's my trig functions again, using that O over H and H over O, finding those values from the equations we wrote down earlier. Moving on, we have two more. This one, on number 19 and 17, you're going to want to reference page 853 for some equalities here. I'm supposed to find x and y. If I look at the sine of 30, it would be opposite over hypotenuse. That doesn't help me. I have the adjacent side. So I can do cosine or I can do tangent. Let's start with the tangent of 30 degrees equals, tangent is opposite over adjacent. That'd be x over 12. To get x alone, I'd multiply by 12 to both sides. And so x equals 12 times the tangent of 30. But on page 853, I'm told that the tangent of 30 degrees is root 3 over 3. So I'm going to say I have 12 times root 3 over 3, which took the tangent of 30 out. Well, 12 over 3 reduces to 1 and 4, so x would equal 4 root 3. All right? To find y, now I need to use, same idea, but I'm not going to use tangent this time. I'll use cosine. The cosine of 30 degrees is equal to the adjacent, 12, over the hypotenuse y. To get y alone, I first need it in the numerator. So I multiply by y, and I have y cosine of 30 degrees equals 12. Now I divide by cosine of 30 degrees, which means I have y equals 12 over, and if I look in my text at what cosine of 30 degrees is, the cosine of 30 degrees is root 3 over 2. Yep, that's right. So I'd have this over root 3 over 2. But I don't actually divide by fractions. We've talked about this before. We can't divide by a fraction. Instead, we multiply by the reciprocal, which gives us 12 times 2 over root 3, which is 24 over root 3, but we know we're not allowed to keep that, so we will multiply by root 3 to get y equals 24 root 3 over 3, which simplifies to 8 root 3. So final answer, 8 root 3. Okay? I know that's a little complicated. We had a lot of simplifying to do, but the key comes from the substitution of cosine 30 for root 3 over 2. All right, last problem we're going to look at is 28. Your job is to solve the triangle, which means we need A, B, and C, little a, little b, little c. We're just looking for the values for each of these. I notice that little c is 10.8. That's my hypotenuse. I notice that big B is 24 degrees. But I also notice that C must be a 90-degree angle, as the picture dictates. And then if I subtract 24 and 90 from 180, I will get 66 degrees as my angle A. Now that I have these, I can use any of the trig functions and either of these angles to try and find my, my little b and little a. I'm going to try the sine of 24 degrees. The sine of 24, which would be right here, is the opposite, which is b, over the hypotenuse, which is 10.8. I multiply by 10.8 on both sides. And I throw that all into my calculator. 10.8 sine 24 equals 4.4. So I'm going to say that b equals 4.4. Now I want to make sure, of course, that my mode is in degrees, which it is. So if you're getting something other than 4.4 from this multiplication, the odds are you've got the wrong mode, and you need to check to find out how you can fix that. Then I'm going to try the same sort of approach, but I'm going to use cosine of the 24 degrees. And that should equal adjacent, which is a over my 10.8 again. I again multiply by 10.8 times 10.8. And a is 10.8 times the cosine of 24, which equals 9.9. One other way to make sure that you haven't done this incorrectly is your c value, your little c, because it's the biggest angle, should also have the biggest measurement, and so on. B has the smallest, so little b should be the smallest. That's a good way to confirm that you've done all this correctly. But that is the notes that I have for you. Hopefully that's enough to get you started and get you through some of those questions you have. But either way, good luck and have a good day.